Welcome to The Explainer. Today, we're unpacking one of the absolute most intense and honestly fascinating debates happening in the software engineering world right now. We're zeroing in on the Model Context Protocol, pretty much universally known as MCP, and how this massive drive to scale autonomous AI agents is just, well, it's fundamentally changing everything we thought we knew about system architecture. Let's dive right in.
There's a saying that every few months, a new technology gets its premature obituary. And yeah, that's a bold claim. But right now, across developer circles, Reddit, forums, you name it, MCP is already being written off by a lot of people. You'll hear developers complaining that it's got way too much overhead, it's too complex, and honestly, just not worth the effort to implement. But to really understand why people are writing those obituaries and why they're ultimately jumping the gun, we have to look at the specific environment those critics are actually operating in.
Look, the skeptics aren't necessarily wrong, at least not if we're just talking about building a desktop assistant or some solo automation project. I mean, for a solo developer, trust is basically implicit, right? You're running isolated scripts on your own machine. In that specific context, sure, using an MCP server does add a bunch of unnecessary complexity. Direct APIs work perfectly fine there. But the second we shift to an enterprise system, the rules of gravity completely change. We're talking about cross-team operations, where trust literally must be explicitly verified. You've got agents acting on behalf of users who might not even know an AI is involved. In that world, relying on direct APIs suddenly creates this massive, gaping audit exposure.
Section 1. The Enterprise Reality. The Nightmare of Credential Delegation.
Okay, so we're officially shifting off the developer's laptop and into the massive, hyper-complex realities of building platforms that run agents for enterprise customers. Just think about it for a second. When an agent is acting across a giant organization, how do you handle identity? If you give an AI too much access, you've just created a literal compliance nightmare. But if you give it too little access, the agent just fails silently, and users completely lose trust. Which really brings us to the ultimate question. Can the AI did it pass an audit? Imagine you're a platform engineer in, say, finance or healthcare. A massive action was just taken on a customer's account. The compliance officer comes knocking, wanting to know exactly who authorized it. You can't just shrug and say, well, the AI did it. Try telling an auditor, hey, the algorithm was just feeling a little creative today, and see how fast you lose your SOC 2 certification. I mean, it's an absolute non-starter. Because when those auditors do come knocking, they absolutely demand three things. They need to know exactly what the agent did, on whose behalf it acted, and under what specific authority it operated. This is that critical context we've been talking about. And here is the real kicker. This context needs to be baked into your system by design. You can't just cross your fingers and try to piece it all together from random server logs after a major security incident has already blown up. It has to be native to the action itself.
And that brings us to the crucial point here. Direct API integrations they fall completely flat in this enterprise scenario. Yes, absolutely, direct APIs are way simpler to set up initially, but they cannot provide this crucial tool call level context. A standard API call simply doesn't natively capture which specific server, which exact credentials, or what specific scope authorize that autonomous agent to take that action. That vital context is completely lost in translation, which means your audit trail, it's broken right from the start.
Section 2. The illusion of allowlists. Why policies aren't governance. So, if direct APIs are a total compliance nightmare for agents, how do developers normally try to fix it? Well, usually they reach for an allow list. And an allow list seems perfectly logical at first glance, right? You define the permitted tools, you check against the list before the AI executes a task, boom, you move on. It feels like governance because it looks like a policy. But why do allow lists actually break down in practice? Misconfigurations, completely unexpected agent behavior, and unanticipated edge cases. A policy is really only as strong as the system enforcing it. AI models are inherently unpredictable by nature. They're wildcard engines. When they start behaving in ways literally no one anticipated when the allow list was originally written, that policy shatters and your security is immediately compromised. And this right here is where the Model Context Protocol really shines, providing a definitive solution known as structural least privilege. Basically, this is an architecture where an agent's connection only exposes the specific tools required for that exact given task. Which means, and this is key, it is structurally impossible for the agent to exceed its scope. Think about the massive difference that makes for a security team. There is a world of difference between hoping an agent follows the rules of some allow list and knowing it is structurally impossible for the agent to break the rules because the unauthorized tools literally do not exist in its connection context. It's a game changer. Section 3. The catch. Current MCP friction points. Now, to be totally objective here, MCP isn't flawless yet. The skeptics out there, they definitely have some valid points, and the day-to-day friction for administrators is very real. First off, capability-scoped server provisioning is just way too manual right now. Setting it up properly requires incredibly deep infrastructure knowledge. And honestly, when things are too hard to configure, administrators skip it. They'll just fall back on creating broad connections and slapping a lazy allow list on it as a backstop. Second, the operational layer really lacks visibility. A security or platform team needs to be able to just look at their environment, see every single active MCP connection, know exactly what it exposes, and know who's using it, all without having to dig through dense, messy configuration files. Until these two hurdles are cleared, scaling this in the enterprise is definitely going to face some resistance.
Which brings us to the urgent, unavoidable reality of enterprise AI deployment today. If your organization is out there deploying AI agents at scale, and your honest-to-goodness answer for how you secure them is, well, we have an allow list, what happens next? Because when a real incident actually occurs, that allow list is not going to save you. Here is the harsh truth. Autonomous agents operating at enterprise scale will absolutely find the gaps in your system before you do. That is practically a guarantee. So what's the mandate for your team? Audit your access, map out exactly what your agents actually need to function, and most importantly, build structural controls, like the ones MCP offers, before those unseen gaps turn into massive security incidents. Because honestly, do you really want to wait for a full-blown breach just to find out if your AI had a little too much context?